Well, hi guys. As promised, this is our next installment in my series of how to become a developer using C#. Today we're going to be looking at threaded programming, multi-threading. It's something that you'll definitely come across in your programming career. It's been been around forever, but nowadays with multi-core computers and so forth being a standard, multi-threaded programming is a must-know. Okay, so what we're going to be doing is I'm just going to show you quickly the old way that we used to do threading. And then Microsoft released something they call the TPL, or the Task Parallel Library, and then we're going to be doing threading in that. I'm again going to be doing it in .NET Core, since I said this is a .NET Core series, but everything I'm doing you can do in the normal .NET framework. So I suppose the first thing we need to do is to create a new project. So we open up Visual Studio, we come here to create new project. And as per usual, we're just going to do a command line project. Okay, so I've already selected it's a C# all platform console application. All right, and yeah, you've got your two choices: console app for the .NET framework or for .NET Core. We're going to be selecting .NET Core, but like I say, everything I'm doing here you can do in .NET framework as well. So what shall we call it? Just say Threading 101. I'm not intending for this to be an extremely long video, but as with all my videos, I don't actually prep them up front. I just talk away and let it go where it goes. So I don't make any promises. It won't be a 10-minute video, but no, it won't be a 2-hour video either. So all right, let it create here. Alright, and there we have it. The console app has been created. Should be used to what it looks like now, hello world and so forth. What I'm going to be doing today, just as doing things a bit different to how I normally do it, I normally just start in the previous episodes, I just start right here creating new functions and so forth. But like I've said, I've always had to put in static, okay, and the reason is because this program class requires everything to be static, because it's starting with a static void main as the main program entry point. Now, typically you don't use static that much. So what I'm going to do is I'm going to show you how we normally do it. All right. So we're starting from a static, okay, but we are going to create a class. All right, for our threaded stuff. So let's just say on our project, we say, oops, sorry, not on the project. Come on. Yeah, sorry, I'm right. On the project, we say add, where's add, and then class. And let's just call it threading stuff. All right, so threading stuff. Okay, interesting name for a class. I suggest you never name something stuff at your job one day, as your boss might not be very impressed with you. All right, you don't have to make this class public. We're not going to be using it outside of our application itself. But what we are going to need to do is we're going to have a method inside here, which needs to be accessible from outside the class. So that must be public, in other words. All right, you'll remember this from our normal object-oriented programming series or episode that I did. So all right, so let's create our class. We'll just call it, well, it's got to be public, and we'll say, okay, and it's of type void, and it is, we'll just call it run it. All right. And of course, just put in the correct capitalization there, run it. All right. Okay, so this is a method that's going to be called from outside of the thread. Outside of this class called threading stuff. Now, what Reddit must do is it must kick off a new thread for us. Now, okay, let me explain threading first. All right. Threading is a way all right, of having, let's say for instance, you have only one CPU and also only one core. Now you don't really get that today anymore. You know, they're all quad cores and, you know, 6, 8, etc. cores. And then you have that running in hyperthreading, and there it's 2 threads per core. Now, but what it really comes down to is, let's say for instance, okay, like this machine is an i7 quad core, so it's 4 cores, but with hyperthreading enabled, it's actually 8 virtual cores. Okay, because it's 2 cores per thread, it's 2 times 4 is 8. So if you've got a 6-core machine, you can run 12 threads, all right, etc. Obviously, the more threads, the better, but hyperthreading is not always better. So what I'm saying is, I have demonstrated this before, where if you, for instance, have, like in my case, a 4-core i7, okay, and I switch off hyperthreading, all right, I disable that. So in other words, it can only run 4 threads at a time instead of 8, but it can run each one of those threads slightly quicker. Okay, so what happens is some applications perform better with a hyper-threaded machine with hyper-threading turned off. So you actually have 4 cores and you are only running 4 threads. But in most cases, all right, that's why if you get a machine that's got hyperthreading as an option, which all machines nowadays basically do, it's enabled by default. Okay, most people don't even know they have the option of disabling hyperthreading, because in most cases, by far the most cases, hyperthreading works better than non-hyperthreading. So 8 virtual cores work better than 4 virtual cores when it comes to doing multiple things at the same time. And because you can do more things at the same time, things seem to process faster and progress faster. Okay, so back onto our class here now. So like I say, we've got this class called threading stuff, and in it we've got a method called runIt. So if you go to our main program, okay, so this is where we come in when the program starts. So let's say I want to create an instance of this threading stuff class of mine now. All right, so I'll just say threading. It's not in a different namespace, so it's in threading stuff. Okay, we'll just call it stuff. Oh, never do that either. But if you watch my other videos, episodes, and so forth in the series, you would notice I keep saying about naming conventions and so forth. This time, hey, we're just quickly going through this, so I'm a little bit naughty. Okay, so we've got a class called threading stuff. We want to create a new instance of it, so we create a new threading stuff instance. Okay, and now we've got the instance, and we can say stuff dot, and our method name should be there. There it is, run it. All right, and if we run this now, that's what will happen. It'll run it for us. And you'll notice that in this class, okay, we are not using static anywhere. Okay, we've moved away from static now, because in this static method we actually created an instance of stuff. Okay, it's not static though. So okay, so if we get back here now, let's say for instance, remember we used to here in the main have a console.writeline hello world. We're going to do the same thing. We're just going to move it into run it. Okay, this has got nothing to do with threading yet. Okay, but we're just setting up a scenario here. All right, so let's say console.writeline and let's just say, well, hello world, hello threading off world. All right, hello threading off world. All right, so if we start this up, okay, what I'm going to do, I'm going to show you, so because the machine delays ever so slightly when you start your program up. So I'm just going to put a breakpoint, okay, at the beginning of this program. And so that initial delay when the program starts up, it'll run through and then get to this point now that I've just put a debug point on. And if I say F5, then everything after that should happen instantaneously. All right, so there's no delay, and you're starting to wonder, you know, why is the threading not working and so forth. So okay, so that's there, and we say F5. So we've basically just done again a hello world app, but using a class now. All right, so all we've done is, well, object-oriented programming stuff. Okay, so let that start up. Okay, and it's getting ready. So this is that delay I was referring to. Okay, it's taking a while. It's loading things up. Program hasn't started running yet. You would think it has, but it hasn't. Okay, things are loading. All right, and now, okay, so it's gotten to our breakpoint. So that means, okay, the initial load up is done, it's ready, etc. So if we just say F5 now, okay, it's going to run through to the end of this program so quickly that we're probably not even going to see it appear inside here properly. So if I say F5, go back there, boom, it's already done. All right, so it's a hello world, okay, or hello threading off world. All right, now what we can do, okay, is so that we don't need this here, okay, I'm going to put a delay in our program. All right, so what we're going to do is we're going to say console.writeLine. And let's just say we're going to say starting. All right, and after that, instead of putting a breakpoint in now, I'm going to like delay the current thread. Now that's the thing, every program consists of one process, okay, at least, and one thread at least. Okay, you've got to have one thread, okay, your main thread on which everything runs. So everything that you see here, the mere fact that it's running on a thread. Okay, remember your computer's got many threads. Okay, so, and everything runs on its own thread, different programs and so forth. So what we can do is we can say to the computer, the current thread, okay, the main thread, we want to pause it for a moment. We want execution to stop. Okay, so we say thread.sleep, and we'll just make it 5 seconds. All right, 5,000 milliseconds, so 5 seconds. So what's going to happen is it's going to start up, it's going to go through that initial delay and so forth. It's going to tell us it's starting, and then it's going to do nothing for 5 seconds. The current thread is going to sleep for 5 seconds, okay, and then it's going to finish and say hello world, you know, non-threading world. So let's run it. Okay, so it's going to tell us now that it's starting. Now 1, 2, 3, okay, we count to 5, and then boom, it goes through and it finishes for us. Hello threading off world. So what we've done is we've actually like I said, a program consists of at least one thread, all right, and that's your main thread, all right. And we've now said with system threading.thread sleep, it means our current thread, okay. Sleep it means delay. Sleep, do nothing, just stop, okay, for 5 seconds, 5,000 milliseconds, all right, for 5 seconds. And then after that, it goes ahead and it does what we wanted to do. But let's say, for instance, okay, we want instead of that delay, all right, even though that delay is going to stop the main thread, all right, we still want our program or our little piece of code in multi-threaded mode to execute. So the first thing we do is we take this new code that we wrote, okay, which is what we want to do in multi-threaded mode, all right. We stick it up here between the starting and the sleep. Okay, so now, I mean, I can tell you immediately what's going to happen is it's going to say starting. Immediately after starting, immediately it's going to come to this point and say hello threading off world. Then it's going to wait, so it's going to run it and then say hello threading off world. And then it's going to wait 5 seconds, then the program's going to be finished. Okay, so let's do that. Let's let me demonstrate that to you. So let's just say done. All right, so we know when the program has come to an end, and we run that. Okay, so it started, it immediately said hello threading off world. Now it's waiting 5 seconds and it's going to say done. Okay, so all right, what we can do is let's just increase this 5 seconds to 7.5 seconds, just because it's a little bit too quick. Let's try it again. Okay, so it's going to say starting and immediately hello world, and then wait 7.5 seconds and then say done, and the program is finished. Okay, so no multi-threading yet. Okay, the only thing we've done that's got to do with threading is we've got the sleep in here. It says take the current thread, okay, and sleep or delay for 7.5 seconds. Okay, but now I want to start getting into this threading, stuff, and make it so that it does it in parallel, in a different thread. All right, so it's not affected by the 7.5 second delay. All right, so if we go into, okay, run it. All right, so what we can do is, just to prove to you my idea, is we're going to put this thread also, okay, into a sleep. Not console. Now, because everything is happening, you know, in sequence, okay, our total delay between starting and done, all right, was 7.5 seconds. Well, this code runs basically instantaneously, so it's whatever that microsecond is, plus the 7.5 seconds that we're waiting, okay, we're sleeping, plus another, let's put in another 5 seconds or 3 seconds. Well, let's just make it 2.5. Now let's make it 3 seconds so we can see easier. Okay, 3 seconds. All right, so it's actually going to take, before we see the done now, it's going to take 10.5 seconds, because it's all the time added together. So it's 3 seconds that we're waiting at this point, plus 7.5 seconds we're waiting here. So that's 10.5 seconds, plus the time for the actual code to run. But there's a nanosecond. It's super fast. So it's basically going to sit for 10.5 seconds, okay? And we can run it, and you'll see that. Okay, 1, 2, 3, 4, 5. Oh, sorry, yeah. So that was 3, okay, for hello world to appear, and then now 7.5 seconds, and then it's done. All right. Sorry, I got my timing wrong there. Let's just do that again. So it's 1, 2, 3, 1, 2, 3, 4, done. Or done. Okay, done. So it's about 10.5 seconds, or not about, it is 10.5 seconds. I just can't count seconds very well. All right. So our problem is that we want to take all this here and stick it on a new thread. All right. So in other words, because the main thread is going to be sleeping for 7.5 seconds and this one for 3, this is going to be sleeping at the same time as the main thread. So this 3 seconds effectively is going to disappear. All right. It is going to wait for 3 seconds before it writes hello threading to the world. All right. But it's not going to be a total of 10 seconds, but still 7.5 seconds. Okay. So let me show you what I mean. Okay. So if we take all this out here, all right, we create a new method here. It's a private, but it doesn't matter. Okay. Private void threaded code. Okay, so this procedure, this threaded code method, is now going to be running in a new thread. All right, so what we have to do is we've got to run it here, we've got to create a new thread and put this threaded code method inside that thread. All right, so and then, okay, so it's just 2 lines of code. It's very simple to create a new thread. Okay, so it's system.threading.thread, let's just call it new thread, okay, equals new, and then it's going to system threading thread. All right, now we've got to give them the name of the class, okay, sorry, of the method that must be threaded. All right, so we call it the threaded code one, threaded code. All right, and we close that. Okay, so, oh, sorry. Now we've said we've created a new thread, but it's not going to run. Okay, it's going to do nothing. Okay, it's just, okay, we've got it there. We've got to actually tell it now, okay, start running. New thread dot start. Okay. Okay. And that's it. So now remember, it was 10.5 seconds, the total time. Well, because this threaded code method is going to run on a new thread, okay, while that 7.5 seconds is counting away, this 3 seconds is also going to be counting away. So the difference between 3 seconds and 7.5 seconds is 4.5 seconds. So in other words, after it says hello threading off world, 4.5 seconds later, we should reach the end of the program and say done. All right, so let's test that. Okay, I'll try again and count in my bad second judgment, but okay, let's try it anyway. So we F5 it. Okay, it's starting up. Okay. Naught, 1, 2, 3, 4, 5, 6, and done. Okay, so 7.5 seconds. Okay, so we got rid of that 4 seconds. So what we can do, for instance, all right, is do another one. Okay, another method. Okay, that's also going to sleep for 3.5 seconds. Okay, so let's just repeat this code. Let's just duplicate this code. Okay, it's not pretty, but we'll just duplicate it. Okay, and new thread 2 and new thread 1. Rename that to 1 and rename this to 2. Okay, and they both execute the same threaded code. All right. So in effect, this method threaded code is going to be running now twice. Okay. Because we said that it should be threaded twice, okay? So 2 instances of this method is going to execute. So that's a total of 6 seconds, all right? So you could think that, okay, if it wasn't threaded, you would be right in saying that it's going to say, you know, hello or starting, okay? And then it's going to wait. Initially, if we weren't doing it in a threaded way, it's going to wait 6 seconds to say hello threading off world, and then 1.5 seconds, 7.5 seconds for the end of the program. So that's 11.5 seconds. So what actually is going to happen now is, okay, this 3 seconds is going to be running concurrently, simultaneously, in a threaded way. So in fact, we've got 3 threads in our system at the moment. We've got the main thread, okay, plus new thread 1, then new thread 2 as well. And these 2 are going to be running at the same time. Well, almost at the exact same time, because it's going to start that one, and then it's going to start this one immediately afterwards. Okay. So, all right. So let's see. It should take the exact same time. So let's just get rid of this code quickly. Let's just count the time. So this is just a single thread running concurrently with our main thread. So this is what we had a few seconds ago. We're just going to run it again. I just want to count it. Okay, come on. 1, 2, 3, 4, 5, 6, 7. Okay, 7.5 seconds. So it went 3 hello threading world off world, and then another 4.5 seconds. So it's 3 seconds, and then we got our message. Okay, 3 seconds. Then 4.5 seconds later, the program finished. Okay, so now what we're going to do is we're going to run this hello threading world twice. All right, but I want to change the words here. Now it's threading on. All right, I should have done that just now already. It's threading on world. All right, so remember, so the program started, and then I counted to 3, and then 4.5 seconds later, the program ended. It should still be the exact same. Okay, even though we're running more code now with 2 delays of 3 seconds, an extra delay of 3 seconds, but the time is going to be the same. So let's go again. So it's F5. Okay, and 1, 2, 3, 4. Okay, so there you can see that it works. All right, so we've written some 2 threads to execute while the main thread was running. All right. Now, typically, I mean, for why you would use a thread, let's just get rid of this thread again. Why you would use a thread is you might want to do some stuff in the background. Or let's say, for instance, while your front end is loading, you want to retrieve something from or update something in the database, which the front end isn't dependent on. You might, like, let's say, for instance, a person logs onto your program. You want to write to the database the time that they logged on. You can stick that in a new thread. So for that moment, that communication is taking place over the network while it's telling the database to update itself with the new time, that the program still continues and that update takes place in the background. That's why you use a new thread. Okay, so you can run things at the same time. All right. Now, the problem is, of course, that you can, I've just shown you now, I just had two threads running simultaneously. But I mean, we can do it another way. All right. We can have two threads running this way as well. All right. So what I'm going to do is I'm creating a loop, okay, which is going to run twice, okay, equals naught. What's it? I smaller than 2 and I plus plus. Remember, I covered this as well in one of the episodes of how to do loops. All right. What did I do wrong here? Hang on, there we are. Okay, get that sorted out there. For into I. All right. So okay, so this will do the exact same as what we did just now. Okay, so it's going to now run. Let's just for fun. All right. Let's just change this to an even bigger number, 10 seconds. Okay. Okay, 10 seconds. So our main thread is going to get to this point and wait for 10 seconds, while our threaded stuff, okay, is going to run 2 threads, each one which pauses for 3 seconds. So in other words, the most amount of time those two take up is going to be basically 3 seconds because they're running at the same time. So our total execution time is going to be 10 seconds. All right. So let's look at that quickly. I'm telling you this because I'm leading up to something. Okay, so all right, and it's going to start, and then 1, 2, 3, 1, 2, 3, 4, 5, 6, and okay, so and that's 10 seconds. Okay, so the entire process took 10 seconds for all this to run. But let's say now a boss comes along and says, no. Whatever happens inside here, I want you to do it not twice. I want you to do it 3 times. All right. So what's going to happen now? How long is this program going to sit and wait? Okay. So if we run it again, all right. So now we've got 3 threads running in the background plus our main thread. 4 threads in total. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so there's done. So it made absolutely no difference in our processing time. It still took 10 seconds, and we did 50% more work from just now. But hang on a second. Let's change this, and we go and make it 5. Okay. Now what's 5 times 3? That's 15. All right. That's 5 more than the 10 that our main thread is waiting in. Okay. So let's see what happens now. Okay. So let's run it again. One, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Took the same amount of time. Why? Because it can run 5 threads at the same time. Okay, this is an 8-core computer or a virtual computer. So, but at some point you'll find, okay, that it can't keep up with your number of threads. So let's say you do something ridiculous. I'm not going to do it now, all right? But let's say we start 5,000 threads. Okay, it's not going to finish it in 10 seconds. Okay, it might. I'm not going to test that now. But I've had many more threads running in Rust on Linux as a test and so forth, and it really can go very high. But the problem is that the processor is in no way optimized, okay, to handle so many concurrent threads and what they call switching, thread switching, because a processor actually can only handle one thread, and through trickery and hyperthreading they allow two threads, okay, which normally works very well, okay, like we've just demonstrated now. But the thing is that time, they call it context switching. If the one thread runs, okay, it's allowed a certain amount of time. A processor only allows something to run a certain amount of time before switching over to another thread and giving it a little bit of time. Okay, so, and that takes time. That's switching from the one thread to the other thread on the one processor, okay? And it might actually be switching not from 1 to 2, but it's got to do 5 or 6 or 20 threads on the same processor, all right? So that context switching takes time. Okay, and when you have many threads, that can actually slow your machine down. So to have something like, okay, you know, let's run 5 million threads or whatever that is, 1, 2, 3, 50, 5 million threads. I mean, that can just, you know, hang your machine entirely. All right. So what should actually happen is that the system, or you as the programmer, should actually see, well, how many cores does the system have, and then make sure that, you know, not much more than that number of cores, there's so many threads actually run at the same time. You can do a test. It's possible that for your particular processing that you need done, okay, you can run maybe on an 8-core or a 4-core, 8 hyper-threaded core processor. You can run maybe 300 simultaneous threads before something starts happening to the system, or maybe 3,000 or whatever the case would be, depending on what processor you got and how many cores you've got, etc. But at some point it's going to cause the system problems if you just let it run free. So if you say, okay, hang 10, all right, I've only got 8 cores, so I'm only going to allow 8 threads to run at a time. Well, you have to write a lot of code now to make sure that only 8 of this 5 million runs at a time. And it's got to step through it. As they finish, you start the next one, and we're not okay. So that can be done. All right, you're not gonna break your machine. Whereas right now we might just hang the machine if you try and run 5 million threads. All right, especially if you're using RAM and so forth. I mean, 5 million threads. Let's say, for instance, each one of them uses a meg. Okay, well that's 5 million megs that you're using. I mean, your machine's going to run out of RAM. All right, so instead of you having to write that code, okay. You can actually let the framework take care of that for you. Okay, it's called a threadpool. Now you probably know, if you're into IT, there's a lot of, we often refer to the word pool, you know, like for instance a pool of connections to a database and so forth, so you don't have a million connections, but the idea of a pool is used a lot. So this we're going to be doing with our threads now as well. So we're going to do a pool. So I don't want 5 million, I don't want to sit here forever and have these things run. Let's say we do 50. Okay, so if we just run this now, I mean, we shouldn't have much difference in time that it takes. It should handle 50 quite easily. So we can run 50 threads simultaneously with a 3-second sleep in each one of them. So that's 50 times 3 seconds is a total delay, but they're going to happen basically concurrently, or reasonably close to concurrency. And let's count it. Let's see what happens. So let's F5, all right. So it's running all 50 at the same time. 1, 2, 3. There's all 50 going through, okay? And then once it's finished with that, okay, and then it's going to count its last few seconds and finish, okay? And there we are. So that's how long it took. So actually it took much longer than just now, okay? The reason for that is because we're running all these threads simultaneously on the processor, and they're all taking time. So at some point you run out of your what do you call it, you know, the number of threads you can run at the same time has got a limit, okay, depending on what you're doing. If you're doing something very quick and so forth, you can maybe, like we did something now, but it took 3 seconds to do it because you put a sleep in there. It took 3 seconds, okay. Could be some code that took 3 seconds, okay. And okay, so even though we stuck it into 50 different threads, all 50 ran at the same time, and you can see it did take longer than our 10 seconds that we initially thought, you know, everything could fit into. because of the number of threads. So if we add another 50, it'll take even longer. All right. So like I'm saying, you can get to the point where you can just crash your machine. You know, you've got 5 million threads running, you're going to crash your machine. So what we can do is we can let it up to the system, all right, to create this pool for us. Okay, so what we do is, let's say, okay, we clear this here, all right, and we say thread pool equals, oops, not new, let's just say pool actually that's a boolean, my mistake. Okay, so it's returning a bool result equals system dot threading dot thread pool, come on, thread pool, all right, and then we have to create an instance. Okay, we just close that, and we've got to have the what, hang on, what am I missing? Oh, thread dot thread pool, I think it is, dot, oh, sorry, thread, it is thread pool there, all right. So what am I missing here? I think, yeah, he's complaining about non thread pool can be like a method. What am I doing wrong here now? Thread pool dot, my mistake, queue user work item, sorry. All right, so we've got the thread pool object, okay, that exists, all right, and we're saying queue user work item. So all we're doing is we're queuing to the pool, we're adding to the pool, putting it in a queue, all right, and the user work item is just another word for a thread, all right, or an item that we want to add to a thread, a work item to be added to a new thread. All right, so what's going to happen is now it's going to ask us for, okay, so it's system threading wait callback. So it's system dot threading dot wait callback, and then we give it the name of the method, and that's threaded code. All right, so what have I done wrong here? Threaded code. Oh, sorry. Cannot be used like a method. What did I do wrong? Oh, sorry, new. Okay, of course. So we've got to create a new one. Okay, so that should be that. All right. And oh, come on. What's going on here? Wait, delegate. Wait, callback. Okay, so that's got to do with this here. Yeah, but what is that delegate? Delegate void object. Okay, we're sending that through. I wonder if this should be. Oops. Nope. What is this now? Private, public. That's where we are. Why is he telling me that I keep not putting in this wait callback? Oh, threaded code. We've done that. And I did say new, so why did I remove that? New wait callback threaded code. Okay, and then this is, so I deleted too much just now. What is it? Is it need a static? Can't remember that it was a static. No, it's not a static. Okay, what was it that I did here? Threaded code. Oh, okay. Object. Oh, okay. That's what he wanted. My mistake. Okay. So it does require, if you are going to use a queue user work item, all right, you have to give him a parameter. Okay. I was going to show you this after this anyway, without the pool, using normal threads. Okay, but well, now we've got to it anyway. So in a normal thread, you could do this as well. The data type, okay, of that parameter has to be of type object. Okay, so you know it's not strongly typed really there. So any object. So you could pass a message through. For instance, what should he show in your hello world here, for instance? Okay, like XYZ or whatever. You can pass something through. All right, but we're not using it now. So okay, so we've got 50 again. Okay. And we will say on polled, did I say that? On pooled world. All right, so let's run it again. And now he's going to make some decisions of how those threads should each run. Okay, it's a little bit more intelligent now. For 3, okay. See, just he's running a few at a time, couple at a time. All right. And even though it may seem like it was about the same speed or whatever, the big difference comes in if we had to, for instance, have 5 million. All right. Those 5 million will not crash the computer because he'll run them as he has resources available to run them. Okay. And I think that's as far as I'm going to go into this is the old way we used to do threading. Okay. Now there are things like, another thing I'm going to be showing you just now with the TPL, with those tasks, is a threaded method cannot return an anything. Okay. Let's say we want to return an int. Okay. And at the end here we say return 1. Okay. Can't do it. All right. You'll notice that he's complaining up top here. Okay, it's not you're not allowed to return on a thread a variable. So even this is now in the work item, but even with a normal thread, you cannot. Let me just demonstrate that to you. Let's just get rid of all this. Let's just get nice neat code again. Okay, and well, we can kill all that and let's just start anew here. Okay, so it's system.threading. Like I say, this is the way we used to do it a couple of years ago. Threading dot, let's say thread equals new system.threading.thread, and we say threaded code. Okay, now remember we're sending an object through, so we've got to tell him what's that object. So let's just, you don't have to, but so let's say we're sending through the number 1. Okay, and that 1, all right, we ultimately want to return from the system again. All right, so let's say it is object I, because okay, and we want to return I, so we want to send it to the object and return it again. It can't do it. It tells us here there's something wrong here. Okay, and what's wrong is this int. All right, you cannot return a function, a value from threaded code. All right, or from a threaded method. Okay, so what's happening here now? Oh, sorry, my mistake. If I wanted to pass that through, so then I'll say thread. Why did I type that with a 4 there just now? But okay, thread.start. Okay, and we're going to pass the value 1 through. Okay, and it will say hello world, and I mean we could say at the end here plus I dot to string, and it'll append 1 to that string. Okay, because we've passed that to the threaded method. Okay, so that's basically it. Okay, this is the old way that we used to do threading. There's many things you can do, of course, more than this. You can like join threads and etc. and have them communicate with each other. Talk to shared code. That's where we'll use the lock the lock object, we'll call it. I'll show you some of that just now when we get to the TPL stuff. So yes, that's the old way that we did it. And all right, so let's move over to the TPL, thread parallel library, and see how things have changed. Okay, so the first thing we do is I'm going to keep this sorry, not method. Well, we can keep the method. Let's just go and say, for instance, no, I still want to have this 300 here. Okay, so now what we do is we create a method a different way now. We create it as a task. Okay, so I'm going to say up top here, just so I don't have to keep typing out system threading. Okay, so it's using system.threading. System.threading. Okay, and then down here we can just say thread. All right, because normally you would say system.threading.thread. Now we can just say thread. Okay, but sorry, what we want to use is task. Okay, tasks. Okay, so now we've got access to task. Okay, so we say we want to create a new task. Okay, just call it my task equals new task. Okay, and we can, okay, we don't have to, we can, okay, what we can use is a lambda expression. All right, so before we call this threaded code, I'll show you how to do it with the lambda expression. Okay, so a lambda expression is a piece of code that acts like a function, all right, which you can pass as a parameter, okay, in a method. So our task here, for instance, now is a method. In this case, it's a constructor method that can take this expression. So we tell them, okay, first we have to start it like that. So this is like the parameter list, if there were any parameters, but there aren't any parameters, all right. But if there was a parameter, like remember just now I sent through like I, okay, you know, that's where you'll send that through, okay. But then we do this, all right, and we can say, for instance, console dot writeLine from lambda. All right, I wonder lambda, some of that, is it with a B, lambda? I can't remember now. Okay, but anyway, all right, so we're actually not using this at the moment, okay. So we're creating a new task by doing just that, okay. So same as with the thread, we've created the thread, we've now created the task. So what we now do is we say task dot, my task dot start. Okay, so start. Okay, same as the thread dot start. Okay, now it's my task dot start. All right, so it's going to do as we expect. Okay, it's going to say starting. Okay, it's going to create an instance of our stuff. Okay, I'll show you just a shortcut way. Okay, because this is a lot of code that we've got up here. We can just do this. Okay, and sorry, like that. Okay, so we're not creating a variable and then on the variable we're calling run it. We're creating it straight out. You know, create the variable in. We're not assigning it to an actual variable, and we're just calling run it. Okay, it's just a shortcut way so that you does want to do it. Okay, if you don't want to keep an instance of your object around. Okay, so again, it's going to sleep for 10 seconds. Okay, so it's going to immediately say starting. All right, it's on a new thread, a new task. It's going to say, I can't remember what it said. Let's just save that. It's going to say from lambda. All right, so it's immediately going to say starting from lambda. Then it's going to wait 10 seconds and then say done. All right, so let's say that. Let's run it. The name what did I make a mistake here with? Oh, sorry, my mistake. Yeah, I took that out there. So okay, let's run it. So it should be immediate, starting from lambda, and then it waits 10 seconds, and then it says done. Okay, so I didn't count now, but it takes 10 seconds. Okay, might have taken a little bit longer because it was setting things up and stuff initially, so, you know, with .NET Framework and so forth. There's many things running in the background as well. Okay, but so in fact, we can take this code. All right. Okay. Well, okay, let's just do this. How did we do this now? Threaded code like that. Okay. Okay, so you can call it directly like that now. All right, so we're not using a lambda. We're just calling a normal method. This is how we did it with a thread, in a system threading thread, and the old way. So we're doing it the same here. So again, it's the same thing. Okay, starting, but okay, there was a 3-second delay, remember, before it said hello. Okay, so, and then we wait our remaining few seconds, and that was a total of 10 seconds. But now, let's say, you'll find, the reason why I want to show you this is, I want to show you the lambdas, is because we basically use lambdas far more nowadays than we used to in the past. Okay, so we'll go back to using a lambda expression. Okay, so we tell them the parameter list, there are no parameters. Okay, and because there's more than one line of code, you've got to put it in a block. Okay, and we do that, and that's done. All right, so we've created it directly this is part of the parameters that are going to the task constructor. Okay, so as a parameter, normally you'd send an integer or a string, or whatever the case may be, as a parameter to another function like a constructor or a normal function. Yeah, we've actually sent them a lambda or a method as a lambda. All right, you'll see a lot of this lately. People code like this nowadays more. All right, so we should see the exact same thing as what we saw just now. So again, it's going to say starting. It's going to wait. It's going to enter this thing immediately, but it's going to first wait 3 seconds. Okay, and then it's going to say, okay, let's do this. Done wait, and yeah, we say start wait. Okay, so what's going to happen in the code is you're going to see immediately it's going to say what was it, starting, and it's going to immediately then say start wait. It's going to wait 3 seconds. It's going to say done wait, and then it's going to be finished with the entire process on the different thread, and then it's going to go back to the main program. All right, and finish waiting its 10 seconds. Okay, so remember, it's going to be running simultaneously. So it's going to be about another 7 seconds afterwards that is going to say done. So let's try that. All right, so F5. So after starting, it should immediately say that it's in the lambda. Bam, bam. Okay, it's going to wait 3 seconds and done wait, and then wait another 4 seconds. Sorry, what's that? 7 seconds, and then finished. Okay, and done. All right, so there we've done it. So I've shown you using the old threading way, okay, and I've also now shown you how to use a task, okay. This is the way we do things nowadays. Not the old task, the old threading way. One nice thing about tasks is that the thread pool, which I showed you just now, evidently is taking care for you now. All right, you just kick off your tasks, and the back end, the framework will take care of how these different tasks actually execute in your process and so forth. It's more optimized, okay, than the old way that I showed you. All right, so that's the one way. Another thing that you can do with a task is, which you couldn't do with a thread, is to return a value. Okay. Now, the way you do that is when you declare the task, the data type, you tell them what's coming back. Let's say it is a string. Okay. Then inside here, we say return a string. Okay. Oh, hang on. Why didn't he like that? What did I do wrong now? Why doesn't he like that return? Anonymous function converted to what? Okay, just to get myself back into the driver's seat again. I just want to do it the old way, having a so it was what was it? Private start task, let's call it. Start top private, okay, string, private string, start task, okay, put our code into it, okay, and then we have to return a string, return some string, okay, which is done, okay, and then inside here, okay, we are just going to call new task, then it is start, where we start task, start task, okay, and it takes no parameters, okay, and now it gives me the same problem. So I did something wrong here. Cannot convert to action. Oh, sorry, of course, sorry. Okay, so task, where's my and okay, all right, so return task done. Why doesn't he like that? My silliness, I had to have a quick check at the code, but I was on the right track, so I just forgot here. Okay, so we're creating a data type, okay, a generic type with type string. So of course, when I create the task itself, I've got to specify also that it's of type generic type of type data type string, and then I don't want to call that anymore. I want to do my lambda expression again. Okay, so let's just get rid of this. Okay, so like I said, lambda expressions, because I'll show you, you know, so the code looks familiar when you look at, you know, somebody else's code, or as you code further in your career, so you get used to the more used way nowadays. Okay, so we specify, sorry, no parameters, and okay, it is a, you could just at this point, for instance, just return a string, okay, and just say hello. All right, that will return a string, okay, into this task, okay, and you could use it, but the thing is, you typically work in multiple lines, all right, when you're working with methods and so forth. You know, there's not so many methods that are one line, but it could be in your case. But if there's more than one line, in other words, if there's going to be a semicolon involved here, so you want something done before hello. So oops, what did I just do? So over here, you want to put a semicolon. Come on, why does he put it at the end all the time? It's just predictive rubbish. Okay, so I want to do something, and then say semicolon. Again, it puts it at the end for me. You know, I'm trying to put a semicolon in there for you guys, just so that you know, all right? But the way to do it the proper way, if you have more than one line, okay, is like I said just now, is to have a block, all right? So we just new line on that, so just so that everything looks nice and neat. We paste our old code. All right, and you see I did return done, all right, and because it didn't work just now, it's because I didn't have this string here. So I specified a generic type on this task class, but when creating the instance, I didn't. Okay, I forgot about that. All right, so yes, so we're returning a value from our thread now. All right, done. Okay, so let's say done. Let's say return done. Okay, let's say return done. All right, so that must go, for instance, back to run it. Okay, we want to return that to the front end. Okay, so we want to return a string. All right, and I think here we need an await, but let's just hang on a second. Okay, so that's no, we just say okay, return my task. Okay, and I think this is where he needs to come on. Okay, return my task. The caps over here was wrong. That's always pedantic about the caps, but they have to be done correctly. Okay, my task. Okay, and I think string. Okay, so returning my task here. That's the problem. How do I do this now again? Okay, so it's just like that. All right, so okay, because this is already a task string, so we are now returning a task of generic type string from our function called runIt. All right, and we're sending that to the front end. All right, so runIt here is returning something for us, and it's telling me it's returning an awaitable string, task string. Okay, and okay, so we now actually want to get the actual string. I called it data. Well, you shouldn't call it data. Let's say it's returning a surname, for instance. Okay, surname. Okay, and if you look at the data type that we're getting back, all right, it's telling us it's a task string. Now, to get that string out of this task string, you say result. Okay, and that will return our string for us. So let me show it to you a slightly different way that will maybe make more sense to you. Okay, so we say task, okay, because this is our return type. Remember, let's call it surname task. Just for fun, we call it that. Okay, task. What did I type wrong here? Task. Oh, I didn't include system threading here. Okay, so system.threading.tasks, where we tasks.task. Okay, so the reason why I'm saying that'll work, okay, it's not returning us our string yet. It's returning us a data type of type task, okay, which contains our string. Now, if we go and look at this actual definition of this runIt method, you see it's returning a task string. All right, remember that's what we just did. Okay, we're returning a task string. So if we go back to the program, this runIt is returning into this thing here a task string. So to get the actual string out, okay, you're going to say let's do a console write on that just for fun. Okay, and so we say do console write, and we say surname, surname, just some fancy writing here. We'll do it just a plus, and then it's the surname task dot result. Okay, so if I just want to make this slightly shorter here, just make it like 5 seconds. Okay, so now it should say to us, once the task is completed, okay, it should say to us surname task, whatever our return value was here. I don't know what it is. My task done, might return. Let's just say Smith. Return a surname. That's the result of our calculation inside here, for instance. All right, is to return Smith. Okay, so if we run it, so it always takes a while to start up. Did I actually press? Yeah, I did. Taking its time. Okay, so it's waiting for 3 seconds or whatever it was. It says surname Smith. That's a return from the multi-threaded code. All right. like I say, with the normal system.threading.thread stuff, the way we used to do it, okay, you can't return it. Okay, you're going to have to do it by using the log statement. You could do that still. All right. I can quickly show that to you. You might need this at some point. Let's say, for instance, you want to communicate between tasks. All right. So let's say, for instance, inside here, let's say we have a counter. Okay, so we have a variable, a field. Okay, private. Let's just say it's an int. Okay, and it is a counter. And it starts at naught. Oops, naught. Okay. And let's say inside here, for instance, let's just get rid of all these things here. Okay, so yeah, we're going to wait 3 seconds, make it 2 seconds. Okay, so what we're going to do here is update the value of that counter. We're going to increment it by 1. So counter is going to be 1. All right. And the return value, okay, is going to be, for instance, well, just the counter. Okay. So let's just say, no, I don't really want to do that. Let me not show that to you, but okay. So, but what we do want to do is we want to say underscore counter plus plus. That's, remember to increment in C#, Java, C++. You can just increment. Remember, that's the exact same as writing underscore counter equals underscore counter plus 1. So that's also incrementing. It's the exact same way. This is just a shortcut way to do exactly that. You can increment it by 2 instead of 1, and you say plus equals 2. It'll increment it by 2. Okay, but let's just say plus plus. That increments it by 1. Okay, and that will work. All right, that'll work. It won't give us a problem. All right, so if we just run this, it's not going to show us anything, but if we just run it, you'll notice we won't get any errors or anything like that. It's returning Smith, and you know, life's good, and done. All right, so all good. All right. Now, if you're reading, okay, from a counter, from a variable, okay, you don't have to worry about threading. Okay, it's when you're making changes to it that you have to worry. All right. So let's say, for instance, we want to return Smith and space and then the value of counter. Oh, sorry. Plus underscore counter. Okay, so this time it's going to return Smith 1 because it starts at naught, and then inside our thread, inside our task, we're going to increment it by 1. So therefore it's no longer naught but 1. And if we return that, so now it's going to say Smith 1. Okay, so we're running it. Okay, there we go, Smith 1, and the main thread is running for its couple of seconds that it had to delay there, and everything is still good. All right. The problem comes in is when we have more than one thread that wants to update the same variable. Okay. Now, in some cases, you know, very few cases, it doesn't matter. The troubles, the collisions it's going to have doesn't really matter. Okay, but in most cases, it really makes it matters. Okay, you don't want that to happen. So what you basically want to do is you don't want two threads writing to counter at the same time. Okay, so what you can do is, let's say we copy this thread. Okay. Well, again, I suppose we can say, let's just create a few of them again. For int I equals naught, I smaller than, let's say 10. So we're going to do 10 of them, 0 to 9, in other words, so 10 of them. And so it's where we I plus plus, and get our brackets in, go down to the bottom here, and do that. Okay, and where did I, again, put in a Boolean equation there, and for int I equals, yeah, that should be fine. I was just going to say, okay, put a space there. Okay, and so it's going to create this task, 10 of these tasks, 10 threads. Okay. Remember just now we did 50 of them. Okay, now we're doing 10. All right, and each of them are updating counter. They're incrementing counter. Okay. So let me just show you what happens. Okay, so we're returning that. We're returning that to that side. I wouldn't really worry about sending it back to the front end. We'll just send it some nothing out. But what we will do is, for every loop, okay, instead of, also we don't really need to return anything here. So let's get rid of the return. I don't want to, in this particular case, I don't want it to return anything. What I do want it to do is to write to the console, console dot write line, okay, Smith and counter. Okay, so it should write to the console now, Smith 1. All right, but remember, what did I do wrong here now? Oh, it's because it's not a task. Let's just, oh sorry, it's because it's returning, yeah. Okay, so I don't want that. And then in the main program, I don't want it returning anything either. Okay, so that's here. So it's just that. Okay, and therefore we don't need surname anymore. All right, so there we go. All right, so going a bit fast. I hope you can keep up there. All right, so what's going to happen now is, so if we just do this for, what did I say, 1? It's for I is smaller than 10. Okay, but let's say for I smaller than 1. Okay, so it's 0. So this thing's only going to execute once. Okay, so it should say to us Smith 1. Okay, come on, no return needed, so it's void. Okay. All right, so if we run this now, we're going to get a Smith 1. Okay, there's Smith 1. It waits the last few seconds and it's finished. Okay, remember those last few seconds are because of this 5,000 here. So 3 seconds after it's waited 2 seconds, it writes it out, and then waits another 2 seconds, sorry, and then it waits another 3 seconds and the program is over. Because remember, the 2 and the 5 are running concurrently. Okay, so, but let's say we want to do this twice. Okay, so we should now get 2 things written to the console, Smith 1 and Smith 2. All right, or whatever the counter is. Yeah, it's obvious it's going to increment. Okay, so for every thread that's running, every task is going to increment the counter. Each one of them are going to increment the counter. Okay, so Smith 1, Smith 2, that's fine. Okay, there's no problem in that. Let's just, we don't really want this here at the moment. Let's just get rid of this line here. All right. Now, he's going to try and take care of this concurrency of accessing this thing. Now, in this case, it doesn't really matter, all right? But let's say we put in, let's make it 100. Oh, no, 50 from just now. Let's see how it handles 50. So, everything is sleeping for 2 seconds, and then they're all updating Smith's, the concurrency number, and done. Okay, what went wrong here? Something went wrong here. Why did it not run? Did I remove the call or something? No, I said run it. Okay, and then from the run it. Oh, of course. Okay. Okay, this is, you get background threads and foreground threads. Okay, so what happened is the program came to an end before that thread had finished doing its work. All right, so I could have shown you that just now as well with normal threading, the background and foreground threads. Okay, so let's just put this delay back in, and I'll make it actually a little bit longer again. Okay, so that those threads have time to actually communicate back to the front end. Okay, so it's running. Okay, and there we go. And it's 2 seconds, and then there's 2, 3, 4, 5, and so they're updating, and all looks good. But hang on a second, we did it 50 times, didn't we? Why is it counting from 2 to 21? And there's duplicates in between. That doesn't make sense. I mean, that's wrong. What's going on here? Okay, well, it's concurrency. It's accessing, all these different threads are accessing counter at the same time. All right, they're writing to counter at the same time. Okay, now when you have multiple threads, that you cannot do. All right, if you're reading, fine. Okay, but if you're writing, you got problems. Okay, so well, there's a couple of ways that you can solve that problem, but the one that we normally just end up using, okay, there's like lock, okay, is the one we use. Now lock is basically a wrapper for a lot of the other ways of doing things. Okay, it really depends what you want to do, but in most cases lock is all you really want. Okay, so what you need to do is, okay, so I first need to declare a variable, but I'm going to show you first how the lock is written, the syntax. So all you do is you say lock, okay, then open and close brackets, because it requires a variable, okay, a parameter. Okay, and then you open your block, okay, and you close your block. After that, what you want to do in a single thread at a time, so the other threads do not have access to it. Okay, to enable concurrency. Okay, so then we'll just say my locker, for instance, the name of a variable. Oh, my locker. All right, my locker. All right, and then up top here, I'm just going to say private static my locker is whatever. I mean, it's just a object. Okay, we'll just call it an int. Okay, equals 1. All right, so my locker, it looks like he doesn't like that. What did I forget? Int is not a, must it be an obj? Yeah, it looks like it must be an object. Okay, so that's fine, object. All right, okay, so you just create yourself an object, okay, and you lock on that object. Okay, so if we run it now, okay, remember all those duplicates we had. Not a single duplicate. Okay, I do wonder why it's only running up to 15 though. Oh, of course, it's because you're running out of time. Okay, again, it's this same problem here as this guy. All right, so you could say, all right, don't end this program until all the threads have completed running. Okay, which is the next thing we're going to be looking at. But let's just change this up to, like, let's say 20 seconds. Okay, so all these threads have got 20 seconds in which to do what they want to do. So we should count beyond 15 now, most definitely. So he's deciding how to run, and you see it's incrementing it very nicely, and he's deciding which ones to run, okay, based on the number of cores I have and so forth. So he's made that decision for me, and there we've counted up all the way to 50, and that counter for 20 seconds just finished counting, and there we were, all good. All right, so if we close that then. Okay, so a way to get around our little problem here of this 20 seconds. Okay, you can't just put 20 seconds in here. We don't know how long it'll take, for instance, for our threads to complete, and they must all complete. Okay, so let's say, for instance, our boss tells us, no, this must run 500 times. Okay, that 20 seconds that it's waiting here is not going to be enough. All right, before all the tasks have run, okay, it'll finish the program and shut them all down. All right, so there must be a different way of doing it. Then there is another way of doing it, okay, and that you get two things on the task class. It's WhenAll and WhenAll. All right, you can read up on WhenAll. I'm going to be showing you WhenAll, okay, because that's what we need for the specific example right now. So if you go here, all right, what we need to do, okay, is create a what do you call it, an array. All right, so we create task array, okay, we'll call it just our tasks, okay, equals new task, let's say there are 500 in there, okay. So I always forget now, I forget about the languages. Is it 500, is that 0 to 500, so 501, or is it 500 in total, so 0 to 499? I think it's 0 to 499. 500 means the amount starting at 0. Sorry, it's all the languages I work in, I sometimes get confused. Okay, so I wonder if in C# we can do the following. Let's just say we create a constant and we say loops equals 500, or let's just say 50. I don't want to. Okay, loop const int loops equals 50. All right, I wonder if I can put that loops in here. Okay, yep, that's good. So therefore we can stick it in here. All right, and we do that. So every time, okay, so what happens is we add the task, okay, to the tasks array that we just created. So what we do is, okay, we say tasks, then it is our current index, which is I, so it's 0, and then 1, 2, 3, 4 up to the maximum number of 499 for 500, controlled by this loops here, okay, and that loops there and that loops there. All right, so tasks I equals my task. All right, so what we're doing is we're running through a loop, okay, and of how many times ever? 50 times. We're running through that loop. We've created an array that can take 50 elements, all right, a one-dimensional array, and then in this loop we're adding our tasks to that array, all right, and then what we're going to do is at the end, all right, it's going to now, remember, kick out of the for because everything is running in parallel. All right, what we want to do is want to say, hang on, don't continue, don't go back to the main program, okay, until all our tasks are finished running. Doesn't matter if it takes 1 second or 20 seconds or 3 minutes. Okay, so previously we were bound by the 20 seconds because we took a guess and said, yeah, it should be about 20 seconds. You can't do that in the real world. All right, so what you can say is come on, okay, I just realized that there's a different way of doing this. I just went a little bit bonkers here. Sorry about that. So what we can do is task T. So in other words, our WhenAll returns a task. Okay, and then we have this little try catch here. Okay, and the trick is, see, we've got the return variable of type T here, is to say t.wait. Okay, so what now will happen is it'll wait for all tasks to be completed. All right, and when they're complete, it'll tell us all tasks are done, and because there's nothing further happening in our program after that, okay, it's just going to say done and finished. Okay, there's no delay anymore after all that. So what we can do is let's go a little bit haywire and let's push up this number a bit. Okay, I know we're going to sit and wait a while for everything to run, but let's say 100. Now I hope you notice that if I'm running them as threads, okay, and they're not in a thread pool, this particular bit of code would actually have executed much faster. but in not all cases. Okay, it's better to stick with the thread pool. But I have heard that the framework is not very good with the thread pool and multiple many threads and so forth. So, but I mean, for most use, I mean, C# is a multi-threaded language. The framework is multi-threaded, so it might not be the best, but hey, it's brilliant. I haven't run into any issues myself with it. For a .NET language, C# is great. So, all right. So, okay. So I've changed the loops up to 100 now. So it's going to take a while. But what we can do is, this sleep here. Let's just get rid of it. Okay. We don't really need it. Okay. I was just trying to prove to you, to show you that some things take time and so forth. Okay. So sorry. Hang on. Did I do this right now? Was that be there? Where? Sorry, it is there. What did I do? I did not line things up properly here now. That should be there, and there. No. Am I right? Oh, of course, I messed up because it's this one that I was playing around with. Sorry, let me just put that back to where it was. Okay, so if we run it now, I'm gonna let it do 1,000 tasks. 1,000 threads are going to run. All right. No delay in them. All right. They're just going to, as very quickly as possible, they're going to increment the counter. Okay. It's going to be locked, so they can access them each. They each have ownership at that moment in time. And they're each going to increment it and then write to the console. So this should be quite quick. All right. Even though it's 1,000 times, but it's 1,000 tasks that are controlled by a thread pool. All right, so here we go. Let's try it out. And there is going away. Okay, it's almost halfway. The thing that's slowing it down a lot actually is the console.write. It actually is quite slow writing to the console. So I didn't time that. We can always put a timer in, yeah. That's lying in system.diagnostics.timer if you want to play with that. Nice thing to have to see how long your things take and to get benchmarks and so forth. All right. I think you've also got system.stopwatch you can look at as well, just for interest sake. But all right. Okay. So let's take this console right out. Okay. So let's see how much quicker it is if we could just maybe see it by eye, how quick it is. We're not going to see anything written to the screen now, but it's only going to say finished. Okay, so done. That's how quick it was. Purely because we weren't writing to the console. Writing to the console is slow. It slowed it down that much. So we had 1,000 processes running there. Okay. Given they were all not running at the same time, they were controlled by the thread pool. But I mean, we can go crazy. I mean, let's say your boss comes in for some reason, you've got 2,500 things you have to run concurrently. Now today, you're working like me. I'm working on an i7 with only 4 cores. Let's say, for instance, the actual machine it's going to run on at the end of the day is going to have 12 cores, so therefore 24 hyper-threaded, so it can handle more threads easier. But we want to see, ultimately it's going to run at 2,500. You normally make that configurable. But let's say our app has to run 2,500 times, okay? 2,500 things, all right? So let's see how this machine can handle 2,500 threads running concurrently but controlled by the pool. So off we go. Let's kick it off. Starting. Done. That's how quick it was. All right. That's very fast. Okay. But one must realize that it's not really doing anything. Okay. It's just incrementing counter. I think let's just make sure that it did actually increment counter. Okay. So let's just say count here so that it writes it out to the screen. Let's just make sure, because maybe it didn't do it. So the counter should now be on 2,500. When it's finished. There we go. Counters on 2,500. So it did actually kick off every single one of these tasks. Okay. 2,500 tasks. That's nice. I mean, and this is in a virtual machine. Let's really have some fun. All right. I don't want to crash my machine, but it shouldn't because of the thread pool. All right. So I was going to say 10,000, but that might take too long. So let's just do 5,000. Let's see. All right. It should work without a problem as far as I'm concerned. Started, done. 5,000 threads ran just like that. All right. So yes. Okay. So that's good. But remember, you normally do much more work than just increment a counter in okay. So this is not really real world example of running 5,000 threads, you know. But yes, it can actually do that. Okay, so now the last thing I want to show you is async and await. Okay, quite nifty. Yeah, so the first thing we'll do is we'll leave this code here. What I can maybe do is just make the screen a bit bigger and you can see it all in one go. If you want to maybe copy it, I don't know. But yeah, okay, so let's add a new class. Add class, and let's call it well, async await. So make it, well, as await for async await. Okay, so all right, so what we're going to want to do with this class is we're also going to have a method inside it, a public method, also called do it. I think the other one was called do it, I can't remember. Okay, do it. All right, and so sorry, this is public void. Okay, so what we want to do is we want to call method 1. All right. Okay, method 1 doesn't exist yet, but we want to call method 1. All right, and we also want to call method 2. All right. But method 1 must run on its own thread, okay? And the program must not continue past method 2, okay? So what I'm saying is we want to start method 1 running on its own thread. We know how to do that. You can create a task, but this is just another way of doing it with async await, okay? So we'll have method 1 running on a thread, okay? While that's running, method 2 will start executing because we'll continue down with the code. But after method 2, we're going to say, okay, don't continue until method 1 is finished. All right. Now, the trick here is that we have to say await method 1. Where are we now? Method 1. Okay. Now, method 1, like I said, doesn't exist yet, but that's the trick, is the await bit there. Okay. So let's go and create methods 1 and 2. Okay. Private, well, let's say we want to return a task int from method 1, for instance. Method 1. Okay. And, oops. Casing again. I don't know what it's complaining about there yet, but private task in. Okay, but what's going on here now? Method 1. Oh, yeah, sure, it's not returning, and that is task could not be found. Oh, sorry, of course. We also don't have a the using system.threading.tasks namespace. Okay, so see, now suddenly it sees task exists. He's happy with it. He's moaning about method because method is not returning anything yet, which we are going to be doing now. So, all right. So let's just say we create a integer, and I don't know, just call it counter again. Say that's what's going to be returned, maybe. Int counter equals 0. All right. And okay. Now, in order for us to have method 1 be awaited on at this point, okay, method 1 must be declared with async. okay? And inside it, it's got to have some code on which we are awaiting, all right? So we say await, and then task.run. Oh, come on. Task.run, okay? And here we're going to run some code, okay? Whatever that code may be, okay? Yeah, let's make sure what this complaint's about. Cannot await method group. What? Oh, sorry. Okay. Come on. Okay, and then that, and then that. Okay, and then what's he saying now? Well, we could probably just use a lambda here again. Okay, so that's fine. Ta-ta-ta, ta-da, 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 and let's say let's make it a multi-liner, and and in that we are going to do our old friend asleep. Okay, thread.sleep. Okay, we're going to sleep for 2 seconds. Okay, let's say 2 seconds. All right. And then all it's going to do is increment counter. Let's say, for instance, counter plus. Okay. And then at the bottom here, okay, outside of the task run, and the wait is now completed. And so we're going to say return counter. Okay. So that's all good. All right. Now, method 1. All right. Method 1 cannot be called. The reason for that is we have to say task. Task. Okay, remember we're returning an int. All right, we're just going to call it a t for now. All right, so method 1 returns a task. Okay, and then we're going to do a wait on method 1, but not going to work yet. Okay, so we do method 2 must also be created, as a by the way, obviously. And method 2 does very little. We don't really care about it so much. It's just to demonstrate something. So private void. This is just a normal method. This isn't an asynchronous method of any kind. So all it's going to do is it's going to write to the console dot write line, and we're going to say, for instance, done method 2. All right, and let's say up here. Okay, we're going to say done method 1. All right, what is this complaining about here now? Await returns, read only structures. The wait operator can be used with the async method. Did I say async? Okay. No. Oh, that is definitely away. Oh, sorry, up top here. Okay, so that is async. Okay, there we go. So that's all our code. All right. So what this is saying now is that, okay, we're going to call it, okay, from our front end. All right. Sorry, let's close that class for now. All right, so we're going to call it from here. So let's forget about this one for now. All right. So what we're going to do is we can create a new, what is it, as wait dot do it. All right. And what it's going to do is, so it's going to say starting, and then it's going to go into this method. And once it's finished with that method, it's going to say done. So what's going to happen inside this method is it's going to start method 1, all right, on a new thread, okay. Then it's going to do method 2 while this is running on its own thread. It's going to then do this, then it's not going to continue with the processing until method 1 has completed. All right, and then it's going to say done method 1 and continue and finish. So what we expect to see on the screen is, because there's this delay of 2 seconds, okay, method 1 is not going to be complete by the time we reach method 2. So it's going to tell us starting done method 2, okay, then it's going to wait what is that, 2 seconds, and say done method 1, and then it's going to say complete. All right, so let's run that. Okay, that did not go according to plan. Oh, of course, again. Okay, again. All right. Now, this doesn't normally happen in your code, all right, that you have to put these things in. But again, okay, we need to give it enough time. It's because it's a console app that runs and completes. Okay, in your normal applications, this isn't going to be a problem. Okay, but we're going to have to give it some time to actually do its work. So system threading thread sleep. Okay, let's sleep for whatever, let's say 4 seconds. Okay, 4 seconds. All right, I don't know why 4 feels uncomfortable to me. It just doesn't sit nice. Let's just make it 3.5. I don't know why I don't like the number 4,000 at the moment, but okay. All right, so let's give it a go again. Okay, so we should see done 2, done 1, and finished. Okay, method 2, done, method 1, done. All right, okay, now actually this done should be at the end. All right, just to say, to do things properly. All right, so let's just do it properly. And let's just give it nice casings and everything so that we know we're working nicely. We can actually see what, okay, done method 1, done method 2. All right, and let's just make this a little bit longer. Let's make that 3 seconds. Now remember, it's 3.5 in total, so let's now make it 5. So it's going to finish and then take another 1.5 seconds and then only say done. All right, so let's run it. All right, it's busy with method, or finish method 2. It's busy with method 1. Finish method 1. 2 seconds later, finished. All right, so remember we called method 1 first, okay, before method 2. But method 2 returned before method 1. Why? Because method 1 is running on its own thread, all right, because of async await. All right, so because we did, we said this await here, all right, and everything was async, okay, and we're returning tasks and so forth and awaiting on, so what happens is we create method 1, which returns to us a task, okay, and remember method 1 is still running, okay, it's still running, okay, it's not finished. Then it goes and does method 2, but we've got this task, all right, this T. Then we go and tell them, okay, go and await till method 1 is finished, okay, then continue. Okay, just for interest's sake, I wonder what's going to happen if I say this. Yeah, it's going to complain. It's warning you. All right, so I think it'll still work. Let's just try it out. So we haven't declared a return type or given it a return type, so but it should still be fine. Yes, there we go, method 1 and then method 2 and then 1. Okay, so it still works absolutely fine. You don't have to give it that return type, but just to get rid of that little warning there, let's just give it a proper, so we do return a type, but we don't actually use it. So like I say, we call method 1, it's running in the background. We continue with method 2, it writes to the console. Then we wait for method 1 to complete, because remember there's this delay of 3 seconds. Once that's finished, we say done method 1 and we complete. All right, so let me just show you all that code as well, so you can see that as well if you want to take that down. Maybe what I can do is zoom in a little bit here for you. Let's go to this other one. Let's go here. Okay, not that big, but okay. So if you see that code and you want to try this out yourself, Okay, so that's all the code. Okay, and that is in the first one. This is the second one. Okay, so it's going, there's that code. Okay, and then the calling of it is your program, and yeah, of course you could do that. And okay, so there's all our stuff running. Okay, let me just change that zoom slightly again, put it back there, and that's basically it for multi-threaded design or coding. There's obviously much more you can do, but this is the basics. This will get you going. Okay, at least if somebody knows, if they ask you, can you write something to run on a new thread simultaneously with something else to speed things up, your answer is yes. Okay, by following this, you actually know of a few ways of doing threaded coding now. Yeah, I can't think that there's anything else I need to say right now. And other than that, good luck, guys, and I'll catch you next time.